Welcome, viewers, to this global field of view, which you know I call a YouTube channel, Mathematics Simplified. We have already seen some challenging topics last time. Today we have another one, which I also discovered that very many people want to view and want to respond over it. And this is permutation and combination. Permutation and combination. It is a short part of the syllabus, basically on HS level, although some colleges require this area. Permutation simply talks about the number of ways of doing something or selecting. To permute, permutation is finding the number of ways when it comes to probability. You'll find this area very useful because you require to find the number of possibilities. For example, in how many ways can we arrange the word drive? Drive. Apart from the meaning, but if you just want to arrange those letters in anyhow, without bothering about the meaning, then you will discover there are so many ways which I would require to formulate and come up with a solution, a simple solution in the form of a simple formula. For example, I can say we can have the first letter D followed by R, followed by I, followed by V, followed by E. That is one way. You can alternate it and you say if I start with the D, I can start with the E, followed by R, followed by I, V. They are the same letters, but they are written in a different order. So this one is one way, this one is another way. You can continue like that. Maybe let me give you a simplest case. Till, if there are 3 letters, you can write as many ways as possible, but this one is simple. You can start with the T, L, I as the second one. You can start with the I, T, and L. Another one. And so on and so forth. You are going to discover that there are many, there are at least many, there are around maybe 5 or 6, I don't know, but we shall discover that. But that's the background about this topic is to understand the meaning of arrangement. So permutation, how do you arrange, and in how many ways can you arrange that one? The problem with many students is cramming. We are not interested in cramming the formula. We are interested in understanding the term permutation. So if you can be able to arrange, then you are coming up to the point. So the way you arrange these letters can give you a formulation that actually you are looking for a number of ways or number of different words, which can all the different forms of a word which come out of the 3 letters. And others also arrange that like that. Now, let us label the first place, second place, third place. Then here you will be able to understand where I'm going to. If the first place is we have to choose a letter amongst these ones, the possibilities are there. How many possibilities can we have to put a first letter here? Remember that we have got only 3 letters. So the first possibility, the possibility of choosing the first letter are 3. Either a T can go here, or I can go here, or L can go here. So we have 3 possibilities. When you choose the first 3, and the first letter is now chosen, now the possibility of choosing the second letter on each of the 3. Remember that there were 3 letters. Once you choose the first one, we are remaining with only 2 letters remaining. So in the second place, we have only 2 possibilities of pushing there a letter. So there are only 2 possibilities. And finally, if the second letter is also chosen, then we have only one choice to choose the third letter. And that is one. What is the interpretation here? The interpretation means that the number of ways of choosing the first letter are 3. So you have got either the first letter can be T, or the first letter can be I, or the first letter can be L. Among these ones, the second letter can now, if we choose this one, we are remaining only 2 choices. So it means you have to select over the remaining ones. And if there are 2, remember each of these ones require. So 3 possibilities on each of the 3, there are 2 for the second. And on each of now, on each of the 3 possibilities, there are 2. That means there are 3 times 2 possible ways of selecting the first and the second letter. And these are 6. Now, over the 6 ways, to choose the third, there is only one way. So you multiply by 1. Very many people confuse that area. I want to demonstrate again that area. For the sake of emphasis, I'm saying if you have got 3 letters T, I, L, if the first is a T, another possibility, the first can be I. Another possibility, the first can be L. All these are possible forms. And if the first was a T, the second can be I. If the first was I, the second one can be T. And if the first one was L, the second one can be also T or L. T. Can choose T. So on the first one, there are 3 possibilities. On the second, we have 2 possibilities because the first is already chosen. And after choosing the second, it means we have already 6 possibilities. And after choosing the 6, then the third choice, the third letter, will require only 1. So you find that there are 6 ways of arranging the 3 letters T, I, and L. Okay, that is one example. I'm going to do the same with the word grave. It would be in the same category. In how many ways can we arrange the word drive? In how many ways can we arrange the letters of the word drive? Arrange the letters of the word drive. We can do the same reasoning. We say the first letter can be taken by any of those letters. The end of them. You can choose either the first one to be D, or the first one to be R, or the first one to be I, or the first one to be V, or E. Those are 5 possibilities. 1, 2, 3, 4. The first position can take. There are 5 possibilities of choosing the first. Now, when we choose the first, there are remaining 4 letters. So, over the 5 possibilities of choosing the first one, we are now having 4 letters remaining. So, the number of ways of choosing the second letter are 4. But remember, they are from each of the 5. The language here is it should be used carefully, because these are 5 possibilities. And on each of the 5 possibilities, we have 4 possibilities of choosing the second. So those are the 20 possibilities. On going to the third letter now, after choosing the second one, we are remaining with the 3, because there were 5. 1, 2, 3, 4, 5. There are 5. When you choose 2 letters, we are remaining with 3. So there are 3 possibilities of choosing the third letter. And after choosing the third, to choose the 4th letter, there are only two possibilities remaining. And after choosing this, the fourth, we are only remaining with only one possibility. And what it means is that there are number of ways of choosing, of select, we can say, of writing the letters of the word drive are, the number of ways are 5 times 4 times 3 times 2 times 1. Whatever you get will be the number of ways. If I'm not mistaken, these are 20, 20 times 3, 60, 60 times 2 is 120 ways. If you are to arrange that those letters, you must be ready to come up with such a value. It's a big value. It means that you need to do a lot of work if you are to be writing down the different forms. There are very many. And such, because of such, we can summarize it. See, the importance of mathematics is to simplify your work. So, to get all this one, you simply tell us that number of ways will be equal to 5 factorial. It will look new, but the word 5 factorial simply tells you write 5 times the following number going downwards until you reach 1. So the word 5 factorial is simply a short way of telling you that 5 times 4 times 3 times 2 times 1. Maybe I can also tell you that with this one you read it as 5 factorial. Factorial. 5 factorial. This is a different symbol. Those are the areas of mathematical language. If you remember, those who have just joined mathematics, mathematics is simply a language of symbols. So when you write 5 factorial, it has a meaning of its own. 3 factorial means 3 times 2 times 1, and so on. 2 factorial is 2 times 1, and we accepted this one. 1 factorial is 1, and finally, you are going to meet also what we call 0 factorial, which is equal to 1. All those are possible. Those are languages. I just wanted to introduce to you because you are going to meet it as you revise your work. As far as permutation is concerned, it is as simple as that. You don't need to over-imagine they are asking you to find a number of ways, number of possibilities. You should not panic. As long as you can at least twice, some 3 ways or 5 ways of your own interpretation. Don't simply gamble with a formula which you don't know. Try it also to manipulate some 3 examples. You will be safe in doing this topic. Now I can also mention the term combination. Combination. It is here. Combination. Combinations are selections. They would think most of the students of HSC, senior 5, senior 6 and above, they are aware of what we call combination. When you go to the university, you are going to meet as many combinations as possible. But at HSC, we have good examples. We have people who are doing MEG, HEG, PCM. All those are combinations. But what does it mean? It means that they are selecting subjects from a particular number. Let me give you a simple example. Given subjects, for example, if these are subjects which are school, subjects math, physics, chemistry, geography, they can ask a student to make a combination of only 3 subjects, as it is being done these years. Can we get a combination of 3 subjects? That is the fundamental question. Can we obtain a combination of these subjects? Those combinations normally we talk about subjects which lead to a course which you are going to take at the university, for example, or at an institution. If, for example, they want 3 from these ones, those of you who want to do engineering, I think you can say, I have to take mathematics, because engineers must require mathematics and physics, plus even chemistry. So those are the 3 subjects. And you take a combination of math, physics, and chemistry, which we know as in tradition as PCM. People just write it as PCM. So whether you write it as MPC or PCM or CPM, you are talking about the same. The arrangement of the subjects, the subjects are different, but actually the combination is the same. MPC, PCM, it is the same combination. They are the same. So the combination is the same. However, when we talk about permutation, the arrangement you have done here is not the same. I think that's where many students get confused. So, a combination of this one from the 4 subjects, we can choose a 3, and another one can choose math, physics, geography, MPG, Another one can choose chemistry, physics, and geography. Those are different combinations chosen from the 4 given subjects. So depending on what you are given, you can make as many combinations as possible. So the fundamental question about this combination is to discover how many combinations can you obtain from a given set of subjects or from a given set of objects. Right. In these combinations, we can also try to write down the possibilities of getting these combinations. Right. So from the 4 subjects, you can see that we can have these combinations: PCA, PCB, whatever. Can we derive as many as possible? And how many can we get? So we have a simple formulation. If you are, this symbol C stands for combination. And if you are choosing from 4 subjects, 1, 2, 3, 4, 4 subjects, we put it up. And we are, if you want a combination of 3, then we put a 3 here. I'm trying to summarize this area in the form of a simple formula. So this one, combination 4, 3, has a meaning which can tell us the number of possible combinations you can obtain from a given set. For example, you are given 4 subjects and you are choosing 3, a combination of 3. How many combinations do we get? So this one means 4 factorial over 4 minus 3 factorial times 3 factorial. That formula will help us a lot if you can try to remember it. It is very simple, and I will give you the general formula for it. But the simplest way of remembering it is 4 and 3. This C mean talks about combination. But combination, selecting from the 4 subjects, and you want only a combination of 3 things out of the 4. This one can be written as 4 factorial, which is the same as 4 times 3 times 2 times 1 over 4 minus 3. 4 minus 3 is 1 factorial. Then times 3 factorial, which is 3 times 2 times 1. That's how we get the answer of such a number. And the combination of 3 subjects taken from 4 is 4. Can even cancel. Okay, let's try to see how can. This is 3 times 2 times 1. Those are very good in mathematics. 3 can cancel very fast. 3, 2, and 1. So you remain with the 4. You remain with the 4 over 1 factorial. 1 factorial is equal to 1. And the answer is 4. There are 4 combinations which you can take from the 4 subjects. I don't know whether where you are viewing, can you imagine those four? Can we get them? Okay. Can we start? We have got PCM. PCM. We have PCG, because we want three subjects which make a combination. Only 3 subjects. PCG. What is P? PM. PMG. Is it there? PMG. Those are 3. Where is the 4th? We have PCG. PCG is there. CGM. CGM. Chemistry, geography, and mathematics. And that's how we get them. I told you, you need to also work it out yourself, not simply to finally, I can also give you a generalization about this phenomenon. Some of you have already met it somewhere, but I need to mention it here that it is fundamental you know this formula. The number of combinations can be found by C N R. Number of combinations. When you are given any objects, taking R subjects is given as n factorial over n minus R factorial times R factorial. That is the general formula for determining the number of combinations. If you are given any subjects and you want a combination of R is like the combination of 3 subjects. If R is 2, you work it out. Let me show you. If you have got 5 subjects and you want to take a combination of 2 subjects only, but you are choosing from 5, then you should have 5 factorial over 5 minus 2 factorial times 2 factorial. You simply substitute and get the value. Remember, I told you that the factorial notation. 5 factorial means 5 times 4 times 3 times 2 times 1. You write the multiplication in the reducing order. Thank you very much for listening, viewers. Continue from there. Dear viewers, there is an important area I want you to understand in this part. Whenever I come here, I want you to remember where they get this information from. Much as you have the knowledge about them, I need to show you the reference where you are also going to search for it, so that you don't walk alone, you walk with the material. So, this information, you can consult a book. Some textbooks are very common, very many, but these are fundamental. We have Pure Mathematics by Backhouse, one page. You look at page 243. That is the chapter 12. It talks about permutation and combination. So that is a very important reference. You are going to get helped a lot when you work. Try to do those numbers as many as possible. Unless you find a problem, you will send your problems to me. But otherwise, that one is a good reference. Work out those numbers. Chapter 12 have exercises 12A, 12B, 12C. All those exercises are very fundamental. You are going to gain a lot of experience. Thank you very much for listening.